Welcome back to The Explainer. If you're building, testing, or really just working alongside AI agents these days, you already know that keeping them on track is easily one of the hardest challenges in the field right now. Today, we're focusing squarely on AI tools, specifically looking at a massive leap forward in how we teach our digital counterparts to actually do their jobs correctly. We're exploring NVIDIA Agent Skills. This is an open catalog of over 110 signed, verified instruction sets that teach AI coding agents exactly how to use complex CUDA-X libraries and AI blueprints. And honestly, the best part? The whole shebang is installed in a single command.
Okay, let's dive into this. Here's our roadmap for today. We're going to cover the hallucination problem, verified agent skills, the technical mechanics, the trust pipeline, the skill card, and finally, installation and deployment. Let's get right to it.
Section 1. The AI hallucination problem and specialized AI mistakes.
So I want to pose this critical question directly to you. How can we actually trust AI coding agents with highly complex, specialized GPU computing stacks? Imagine you ask an agent to write a QOpt routing problem from scratch. If you've ever tried this, you've probably watched the agent churn out some really plausible-looking Python code that confidently calls methods the actual API doesn't even have. Or maybe it puts them in the wrong order. Or, my personal favorite, tries to hit a server endpoint that it completely invented.
This happens because AI coding agents make what we call confident mistakes. It's kind of like dealing with an intern who has literally never seen the software but assures you they're an absolute expert. Why does this happen, though? Well, it's because training data for specialized libraries is incredibly thin, and it's often outdated. If your agent is working on a basic commodity web framework, it has millions of public examples to draw from. But for deep, highly specific surfaces like the CUDA-X ecosystem, that massive pool of public training data simply doesn't exist. There's no feedback loop telling the agent, hey, you just cited a deprecated parameter. And this brilliantly illustrates the contrast. Without agent skills, you have this chaotic baseline of hallucinated methods and outdated APIs. But with agent skills, your agent is anchored to verified, NVIDIA-authored guidance. Instead of just crossing your fingers and hoping the model has magically seen enough correct examples, you're injecting the exact correct architecture right into its brain.
Section 2, NVIDIA's Verified Agent Skills, the open capability layer. Now, what's really interesting about this is the sheer massive scale of the catalog. We aren't just talking about a couple of helpful markdown prompts here. NVIDIA has published over 110 verified skills spanning across 24 different product lines. That is huge.
Just to ground this narrative in some specific examples, look at the breadth of the workflows supported here. For data science, there are skills for QDF, teaching the agent GPU data frames, and Pandas acceleration. For vision AI, there's DeepStream for perception pipelines. For optimization, you've got QOpt for complex vehicle routing and linear programming. The team that actually ships the library is the exact same team writing the instruction set for your AI. So how is all of this actually structured? Let's transition over to the architecture.
Section 3. How agent skills work. Technical mechanics. Think of an agent skill kind of like a highly secure recipe card tucked inside a portable folder. Inside that folder is a skill.md file containing YAML metadata, things like the name and the description of the skill, along with the specialized instructions for the agent itself. What's absolutely fantastic here is that this architecture is based on the open standard developed by Anthropic and maintained by Versal. It's a really lightweight, cross-product solution, which means a skill built this way isn't permanently locked to just one specific AI agent. Agents load these skills through a pretty clever mechanism called progressive disclosure. First up is discovery. At startup, the agent only loads the name and the description of the skill. Second is activation. When you give the agent a task that actually matches a skill's description, it activates. Third and finally is execution. The agent then reads the full instructions into its context window. Because this full instructions only load when they're actually needed, your agent can keep dozens of skills on hand with a really, really small context footprint.
Section 4. The Trust Pipeline and Enterprise Security. This introduces a concept called capability governance. It's all about ensuring the instructions an agent uses are transparent, proven, and rigorously verified before they're ever deployed. You see, scaling agent use across a team requires way more than just runtime guardrails that stop an agent from doing something bad in the moment. You actually need to trust the capabilities that are entering your workflows in the first place. Let's move to and see how this builds a verifiable asset. Every single NVIDIA skill goes through this trust pipeline. It's cataloged directly from authoritative source repositories, it's scanned for risks, signed with cryptography, and documented thoroughly.
It's really a complete journey from a vulnerable raw text file into a highly verified enterprise asset. Let's look a bit closer at that scanning phase because it's super important. NVIDIA runs these skills through an automated risk scanning process called SkillSpectre. It checks for your conventional software risks, like vulnerable dependencies, but more importantly, it scans for agent-native risks. We're talking about things like hidden instructions, prompt injection, and trigger abuse. If a skill has any mismatch between its declared purpose and its bundled behavior, SkillSpectre absolutely blocks it before it's ever published. Next up is the signing phase. Every single skill ships with a detached open SSF model signature, a verifiable skill.oms.sig file. This is checked directly against the NVIDIA Trust Anchor. This cryptographic signing ensures true, verifiable integrity post-download. I mean, this is a massive upgrade from just copying and pasting a random markdown prompt you found on some developer forum, right? You can mathematically prove the skill hasn't been tampered with.
Section 5. Inside the skill card, centralized trust data. So the crucial point here is that every verified skill comes with a skill card. This is a machine-readable record detailing exactly who built the skill, what it depends on, its technical limitations, and its verification status. Because it's all housed in a single standardized YAML file, developers and enterprise architects can rapidly assess compatibility and risk without having to manually audit the entire skill folder themselves.
Section 6. Installation and deployment. Governance implementation.
And getting this running, it is implemented in exactly one command. You just run npx skills add NVIDIA/skills. That is literally it. Contrast this incredibly simple one-command installation with the rigorous cryptographic machinery and trust pipelines working behind the scenes. You get full enterprise-grade capability governance delivered through a single elegant node command. And the compatibility is just fantastic. Because it uses that open specification we talked about, you don't even have to change your favorite coding agent to leverage NVIDIA's capability governance. Whether you're using Claude Code, CUDA-X, Cursor, or the Kiro CLI, the command simply places the verified skill into the exact project or global path that your specific agent is already expecting to read from.
The workflow itself is entirely interactive. You run the npx command, you choose a skill from the prompt, and then you select the agent installation destination. There is absolutely no need to manually clone repositories, dig through folders, or copy files by hand. The CLI handles the discovery and targeting seamlessly for you.
Let's anchor this entire process in a really concrete before and after example. Once installed, your workflow is completely ambient. You just say to your agent, hey, solve a linear programming problem with QOpt. The agent recognizes the task, activates the QOpt skill, and automatically applies the verified Python API. It uses the correct parameters, the right endpoints, and the right initialization steps. No more confident mistakes. Which brings us to the ultimate takeaway. If we can now cryptographically verify exactly what an AI knows and tightly govern the capabilities it brings into our enterprise workflows, well, what other capabilities should we demand our agents prove before we let them write our code? NVIDIA Agent Skills represents a fundamental shift from just hoping an AI knows the answer to systematically injecting verified truth into its process. Thanks for joining me on The Explainer, and keep learning.